What would it take to make North Texas an artificial intelligence center of the United States? We started down that road in 2017 when M2 went live. And shortly after that, we got involved with implementing the 2016 to 2025 SMU strategic plan. And there's a specific item in there that is to foster high-performance computing and give more capability to faculty.
The infrastructure required to bring these things in is very substantial. And the fact that SMU actually has this level of a data center that can accommodate something with this with very little modification is very difficult to do.
So we started with infrastructure at the farthest edge, which is the internet, installing 100 gig network infrastructure, core upgrades, firewall upgrades. We've been trying to make a large investment in the network infrastructure to be able to be in a position to where we can actually accommodate something like this.
This, by far, is one of the most awesome machines that you can use for artificial intelligence.
The SuperPod is 20 nodes. A node is just an individual computer. Each of the nodes has 8 NVIDIA A100 GPUs, and they are very good at basically doing linear algebra type operations, such as matrix multiplication. And matrix multiplication is at the heart of machine learning and AI applications. The real horsepower is happening on the GPU itself.
Graphical processing units are especially good for AI. Now, you might wonder, why does graphical processing and AI have anything to do with each other? It's the fact that images are large matrices, and what graphical processing units are specifically good at is matrix operations. And so that's what's really valuable in AI.
This is part one. We have just released an RFP for a new, what would be a standard compute HPC, which will be the replacement for what is now M2. And it will be the SuperPod, and this environment will play in tandem with which should be really a top of the line HPC environment to better research activities in North Texas overall.
The biggest thing is just forward march with scale, right? So a lot of applications and research that's done on HPC systems are about basically taking this idea and then scaling it out, right? So you're doing bigger data sets or more exact simulations or things like that. And when you do that scaling, it takes more computational power, right? And so the SuperPod and M3 bring to bear a lot more compute power. And all that compute and all that extra memory and storage and everything that goes along with it just allows the kind of cutting edge research to go another level up, right? In terms of what is possible to do on an HPC system.
So between those two pieces, you can solve GPU problems and CPU problems, which means that you can program just about anything. Fortunately, our team has experience running both sides of that.
Whereas the SuperPod is a piece of technology that sits in the data center to do cool things, I'll say that my team is like a SuperPod of people that sits over in the Forward Research Center and really covers the spectrum of where we're going with computational research. What we'd noticed was that many times, in order to serve especially our computational research needs in data science to do new things or high performance computing, we were increasingly having to borrow more and more of existing staff. And so my team begins with that story. Can we hire some people in information technology that were dedicated to just partnering with faculty to solve research questions?
My background's in physics. On my team, we have a computational chemist, an applied mathematician, and a computational hydrologist with a background in civil engineering. So we're hard scientists. We're kind of working with faculty who really, they try to train models to solve problems that people aren't good at solving or takes people a lot of time.
The thing that I probably enjoy the most is the wide variety of interests and projects that faculty across the campus pursue, and getting to be a part of that and the challenges that come along with it. The more daunting, the better, I like. Being able to kind of hop from research project to research project and be a part of pushing all the research across campus forward is probably the thing I enjoy the most.
These are not your traditional IT people. These are people who have the tech skills, but also a deep background in what the research process is and what research methods are. And not only are these people able to develop partnerships of trust and projects with faculty because they understand what faculty are trying to achieve, but they're also teaching our larger OIT organization to be more adept and understanding of how we need to adapt some of our services to serve research a little more effectively and efficiently.
What's great about when a faculty member who's not so familiar with HPC gets onto it for the first time is, they get comfortable with it, and then very quickly they see the scale that they can do. They were doing their problem at some level, and maybe they were doing it on a workstation in their office or their laptop or something like that. And then they get on to M2, or now the Superpod or M3, and they realize, oh, suddenly I can do 1,000 times bigger, right? I can take whatever data set that I was working on and multiply it by some factor, or I can turn over a lot faster, right? So instead of waiting hours or days to get the computations done, I can run them much more quickly on a bigger system.
We get to come in and say, have you tried something new? Or they come to us and say, I have this crazy idea, and we get to say, well, let's make it happen.
There's so much capability in these machines that it just takes a long time to understand what it can do for you. But the fortunate thing is we have the expertise. Between the 5 members that we have now, dozens of years of experience programming high-performance computing.
We're only scraping the surface of faculty who are increasingly asking questions of, well, how do I get started? How do I learn more?
First would be dream big, and then I would bring our team over there to talk with the faculty member, talk with their graduate student, see what problems might be solved with a bigger computer, whether it's M2 or it's the Superpod or it's the new M3 machine.
Every day can be different, and so that's what working with faculty really brings. I work with a faculty in history, I work with a faculty in anthropology, I work with a faculty in physics, chemistry, biology. They bring the subject matter expertise in their field, and I get to come in and learn a little bit and then add value from me and my team. We like teaching students how to get on the system, how to be good stewards of shared resources. You don't want to require your models to be these huge sprawling things if they can be tighter and better stewards of the data.
So a lot of the people that we actually interface with, which are the grad students and postdocs, and I would like them to know that they don't have to go it alone. Focus on the research that they're doing as part of their studies if they're a PhD student, or as just being a postdoc, but that we can help them optimize those workflows so that they can basically get to science faster.
The Superpod really helps SMU differentiate what we're able to provide for research and what we're able to do with research ideas.
When it comes to innovation, there's no other university that I'm aware of in the state of Texas or really anywhere near us that has this type of infrastructure that's positioned to actually build an infrastructure like this and then utilize an infrastructure like this. And so what a great opportunity to build really something that's so future-facing. No one else is doing what we're doing here at SMU. We are kind of that field of dreams. We are in a position where we've built it, and we want the faculty, the students, really the entire community in the world to know that we have got this system.
If anyone on campus has interest in research computing, in finding out more about high-performance computing or mainframe, or just I have a research question and I want to talk about it, more than anything, I just want faculty to know we're here and we're here to help.
We are at a position in OIT where we have the hardware and the people, and we're ready to support R1.